Okay, this is a lesson 5.6 supplement. We're going to talk about something called Newton's law of cooling. It relates to what we did last day, where last day we looked at a mathematical model where the rate of change of a variable is proportional to the variable itself. What was the differential equation that described that? Yeah, dy dt equals to k, right? That's the constant of proportionality times itself, which is y. And when we did the separation of variables and all that, we came up with the equation y equals c e to the kt, where of course c was a constant. Now, Newton's law of cooling says that the rate of cooling, oops, I spelled that wrong, cooling of an object is proportional not just to the variable itself, but the temperature difference between the object and its surrounding. Provided, of course, this difference is not too big. Okay? Difference. It's not too big. So how does this change our differential equation? Well, we still have dy dt, but this time it's not k times y. We now rewrite this as y minus perhaps its surrounding temperature or surrounding variable. So I'm going to go y sub s. Okay? Where of course y is just the temperature and y sub s is the surrounding temperature. Okay, so let's see what happens when we look at example number 1. A bottle of soda pop at room temperature, which is 72 degrees Fahrenheit, is placed in a refrigerator where the temperature is 44. After half an hour, the soda pop actually cooled. The question I have for you is, what is the temperature of the soda pop after another half an hour? So pretty much an hour after it started. And then part B says, how long does it take for the soda pop to actually cool to 50 degrees Fahrenheit? So, if I want to do this, I really should be looking at the differential equation, dy dt equals to k times y minus the surrounding temperature, which in this case is the refrigerator temperature, minus 44. Okay? Now, let's see if you can separate the variables and integrate. So, dy over y minus 44 equals to k times dt. We can integrate both sides, and then you get what? The natural log of the absolute value of y minus 44 equals to kt plus c. Going to solve for y, not natural log of y, so we'll then e both sides. And then we get, of course, the absolute value of y minus 44 equals to e to the kt. And remember, this is e to the kt plus c, or I can write this as e to the kt times e to the c. And this e to the c is just another constant, so I'm just going to write this as c e to the kt. And because I have the absolute value, that absolute value can be also incorporated into that constant with a plus minus. So I can just leave it as y minus 44 equals to c e to the kt. Okay? Now to solve for c, we're going to have to use some initial condition, and the initial condition here is 72 degrees Fahrenheit, so use the initial condition to solve for c. So 72 minus 44, c e to the 0. Of course, when time is 0, e to the 0 is just 1. So we'll see that c equals to 72 minus 44, which is 28. And therefore, our equation now is y minus 44 equals to 28 e to the kt. Or, if you want y by itself, then y equals to 44 plus 28 e to the kt. Now, we're still not done because we need to solve for k. So I'm going to move back up here and say, okay, how in the world am I going to solve for k? Well, I do have some other information here. It says, after half an hour, the soda pop cooled to 61. So, to find k, I want us to plug in this piece of information, right? In this case, t equals to 30, right, after 30 minutes. And then the y value is actually now 61. So plugging it into that equation again, and our equation is y equals to 44 plus 28 e to the kt. 61 now equals to 44 plus 28 e to the 30k. And now we'll just do some algebra. So 61 minus 44, what is that? 17, I guess. 17 equals to 28e to the 30k. We can now solve by dividing both sides by 28. Taking the natural log. And then, of course, solving for k. It's the natural log of 17 over 28 divided by 30. And if you're curious what that is as an approximate decimal, negative 0.01663. Okay? Now, I actually prefer if you keep it as natural log, but if you want to use decimals, go right ahead. Anyways, all this work to really say, okay, now I finally found my equation that describes this scenario. Voila. Okay. So now I think I can go and start answering the questions. So what is the answer for part A? Well, remember part A says what is the temperature of the soda pop after another half an hour? So I really want to solve for y. And this time I want to plug in the value of t being equal to 60. And I'm going to spare you the trouble of doing it in the calculator, but you should really double check yourself so you know how to plug this into your calculator. I got an answer of 54.321 degrees Fahrenheit. Okay. And then for part B, how long does it take for the soda pop to cool? Then of course you're trying to solve for t by making y 50. We'll just do some algebra here. 6 equals to 28 e to the negative 0.1663t. We'll divide both sides by 28. Take the natural log of both sides. Divide by that ugly decimal. And once again, I will save you the trouble. I will just tell you what the calculator spit out for me. The answer was 92.619 minutes. 92.614 minutes, sorry. So about a half an hour. More than 60 minutes. Okay. There you go. Now, what I'd like you to try is to see if you can do example number 2 yourself. Okay? Same kind of idea. So I'm hoping that you can set up the equation. And if you can't, come back and double check your answer with what I wrote. But once again, same kind of idea, same kind of separating variables, same kind of question. So go ahead and try this yourself. Press pause and come back and double check your answer with me. If you're not too sure about the steps, of course, play the video so that you can double check that you're doing things right. Remember the surrounding temperature in this case is the room temperature, so that's 20. We will anti-differentiate here. Da, da, da. Natural log. See, this process is all the same. The only difference now you see is y minus 20 equals to c e to the kt. You're going to plug in the initial condition. In this case, the initial condition is 5. So I'm going to say 5 minus 20 equals to c e to the 0. C equals to negative 15. Interesting, this time the c value is negative, which kind of makes sense, right? At least I hope it does. Y then equals to 20 minus 15 e to the kt. Gotta plug in the other piece of information after 25 minutes. So when t equals to 25, what do we get? The temperature is now 20. Oh, sorry. The temperature has increased to 10 degrees. So 10 equals to 20 minus 15 e to the k times 25 minutes. We'll do some nice algebra here. That would be negative 10 over negative 15 equals e to the 25k. That's just, what, 2/3, I think? So natural log of 2/3 equals to 25k. I'm skipping a few steps here, but nonetheless, it's the same process as before. That's why I'm doing it like this. K is, what, negative 0.01621. So the equation equals to 20 minus 15 e to the negative 0.01621 t. Yeah. Okay. Now we can go answer our questions. Temperature after 50 minutes. That's right. Plug in 54T. And I'll tell you your answer is about 13.333 degrees Celsius. And for part B, whoa, what happened there? For part B, when will it be 15? You just plug in 15 and go ahead and solve. I don't want to write this down anymore, but I'll just say ... I got something like 67.74 minutes. Okay? And I hope you got those answers too, because if you did, you got this. Okay. Example 3 is somewhat the same, so I don't really want to do this with you again. I think what I will do is I will write down a few things that might be important, and I'll give you the final answer. But you know, this is an example of what they actually do at the morgue, and how math is involved with murder investigations. So if you like that kind of stuff, CSI stuff, you could be a mathematician and be involved with that too. Okay. All right. So in any case, you try. Okay, and we'll come back together to double check. This, of course, comes from this statement here. An hour later, it was 30.3. An hour later, so t is 1. You'll find k equals to what? Natural log of 10.3 over 12.5 over 1. And then if you just go ahead and find out when did the murder take place, you can plug in the values, and you're trying to solve for t, and I'll tell you that the answer would be 11:55 a.m. Okay? All right. I hope you got this. If you do, bravo.